So we have a few questions coming in here. Thanks for our experts ashore for tuning in, as well as the public. Yes, we'll be heading to Astoria, USS Astoria. I think in about 3 hours or so, we should be arriving above the wreck site, and we will be doing a somewhat similar type of survey that we did for the Vonsen, and that will consist of an orbit survey to start above the wreck. So that'll give us a kind of high resolution map of the wreck that will help us navigate and understand kind of where we're located before we get down to the seafloor and do a visual survey. And that visual survey will circumnavigate the entire wreck and notate what we're seeing throughout that circumnavigation, and return to specific sites of the wreck that we'd like to do some additional imaging after we've gone around it. So photogrammetry might be involved, but we also prioritize getting some high-resolution digital still images of the key points around the wreck. So while our operational team in the front row are still getting set up, maybe we can just start with a little back row introductions here. And Hiroshi, do you want to start off and give us an introduction of who you are and what you're looking forward to with this cruise?
Yes, my name is Hiroshi Ishii. I'm a project. Hello. My name is Hiroshi Ishii. I'm a project specific researcher for maritime Maritime Asia Heritage Survey at the Center of Southeast Asia Study at the Kyoto University, and then I'm here as a maritime archaeologist. And yeah, by myself as a Japanese, so I'm looking for some Japanese shipwrecks, and then yeah, looking for some yeah.
Fantastic. All right, Bill.
Hi y'all, I'm Bill. I'm here as a ocean science intern. Right now working as a data logger, so anything cool we see, anything that goes on during the dive, I record. And I also take cool photos if given the chance.
Awesome. And my name is May Lubetkin, and I am one of the science managers on the ship, and currently sitting as watch lead for this watch.
Hello, sorry.
Yeah, go ahead,
Troubleshooting
Jacob.
some video stuff. Hi, over at the video station, I'm Jacob Ottaviani, video engineer on watch. On this cruise, I am also the ship's documentarian, so I'm running around sticking a camera in everyone's face as they're trying to get work done. When I'm not on Nautilus, I am also working for OET as the video production coordinator, where I edit all of the highlight videos that go out on the YouTube page, across social media. Pretty much if it comes from an OET online platform and it involves moving pictures, I touch it at one point or another.
Awesome, thank you. And then our ROV operators and navigator they'll give us introductions when they're settled and ready to go. So currently we're just transiting between wreck sites, and we see a sort of soft sediment seafloor below us. And if we see anything of note on the seafloor, whether that be something biological or traces of a wreck, perhaps armaments or things like that, we'll take note of that, but continue moving along so we can get to Astoria as soon as possible. All right, folks. So our operations team in the front row are now ready for some introductions. So why don't we start with Jacob, our navigator.
Hi, everybody. So my name is Jacob Stock. I work as a navigator on board the Nautilus, responsible for keeping communication going and helping our ship be positioned whenever we're doing our ROV dives so they don't have tether to move freely. When I'm not on board the boat, I work as a ocean mapping engineer for the University of South Florida. And yeah, that's it.
Tim, whenever you're ready.
Can you hear me, Tim?
I think his headset is, yeah.
Tim's playing with his toys up here. Roger. So that's a funny thing. Roger, 50 meters. Even though it updates faster, and I have a lot of trouble with it because I'm old and I can't see, and they're not in a sensical order. It's always heading depth altitude, heading depth altitude. But it's worth noting, Tim, that nothing happens that fast, that you need that fast of an update. If it does, you're dead. So an analogy maybe is, you know, the difference between a car, helicopter, and an airplane, or a boat. So Hercules is very much like a boat, and a very, you know, not very powerful. The only difference is it goes up and down, but the velocities, how the velocities work, are very similar. You're moving 6,000 pounds of ROV around with 20 horsepower. And with Atalanta, where that might be critical if you were like doing a carrier dive and we were, you know, within 2 or 3 meters of the bottom with Atalanta only, how we did on the carrier dives. But other than that, the one I go by is my delta. So the reason you see that wonky now is because Herc is light, so it's floating up as we tow. And I could, we'll see. So generally I like to keep that single digits above, or while we're towing, or while we're ascending or descending through the water column. The danger of it being up above Atalanta is it can, you know, if everything went haywire right now, we would get wrapped around the umbilical. So what we are going to have to watch here, I forget it's in the chart on the dive plan, what the depth is at the other end of this 3.5 or 3.5 hour tow. It's probably worth noting. Or I could just ask the navigator. What's the depth at our destination?
1 second.
It's right there in the dive plan.
It's 8:52.
152 meters.
8:52. So we're going to come up 100 meters. So if we don't pay attention here, we'll, like if we kept our current depth, we would at some point plow.
Roger, and you're not auto out anymore, you're just getting pulled along?
Right now I'm just getting pulled along. So what I'm going to do, instead of auto out, because the autos are kind of hard on the vehicle, they're on and off, on and off, on and off. And it's like sitting there, you know, if you're with your gas pedal, just put a little Z-bias in. So we'll just turn this knob here, and generally if we have the vehicle ballasted nicely, that's going to be 20 to 30% somewhere. We'll keep it. And when you're flying it, when we're not getting towed all over the seabed, it's nice to have some Z-bias in, so you don't have to be on and off your verts. But that's personal. You know, everyone will be a little different. The nice thing about dialing the Z-bias in where the vehicle is basically not drifting up or down is when we're doing the flying zooms, so we can zoom in. If it's not, then you're manually correcting, and the pilot can't.
Gotcha. Does that change based on circumstance, based on depth? Like, are you always tweaking?
Absolutely, always tweaking. Usually when I first sit down here, I'll turn it off because I want full control of the vehicle. And it'll change during a science dive if we pick up a rock. So the ballast on the vehicle changes, so you need a little less Z-bias because it's heavier. Depth definitely changes it. And it can also be more desirable to have that or not have that, depending on the current and the, you know, whether you're coming up a steep hill or you're flying across the flat or whatever. So that, and I don't know what I think we're a little light. If we're ballasted perfectly, 26 will hold it neutral. Or we try and go in minus 50, so we're 50 pounds buoyant. Well, this is going to be a boring 3.5 hours. I tried there at the beginning. We were occupied up here, so we were getting the vessel, moving at 1 knot, and we were getting so the vessel comes up to speed pretty quick, and that's telegraphed down to Atalanta fairly quickly because we're only at 1,000 meters. And I was trying to get Herc lined up to stay 20 meters in front of Atalanta and 15 to 20 meters below it. And I was struggling with, we have a little bit of cross current there, as you can see, maybe, I don't know, it was drifting me off to the west. So then I was trying to crab into it because Hercules has 2 small lateral thrusters and they spin very fast. So that means if we're really using those, it takes a lot of our hydraulic pressure and flow. So we can have any of 4 thrusters fully engaged, and you won't see this pressure drop down. But the laterals actually take, even though they're smaller motors, they take more flow because they're spinning so fast, because they have a smaller prop. So the bigger props limit the speed of the motor because they're digging into the water. And anyways, yeah, my pressure was dropping down, so when that drops down, then you have even less authority with the vehicle. And I was trying to balance that where it wasn't. So you can see here what the thrusters are commanding. And it was, 50% or more. So I had it at one point, and then I didn't have it, and then I would get too far in front of Atalanta or too far behind it. And so I also try to use, Hercules has this auto XY functionality. And I've successfully used it like a 1/2 knot or 3/4 of a knot. Usually when we're doing 1 knot, I'm manually flying but I thought I would try that. So it worked for a little while, and then it didn't. These are usually at like 0.15 or whatever. And so that's the maximum velocity that when you go into velocity mode, the vehicle's adjusting its command to the thrusters to maintain a certain velocity over the seabed based on what it sees from the DVL. And if you turn your joy gain up and down, then it's some percentage of that
Okay.
max velocity.
So the auto XY value is a coefficient of your joy gain.
Yes, it appears to be. We're
That's
pretty certain it.
an interesting choice.
Yeah. And I don't know if it was a choice. I think it was more of a feature. And there's been a long discussions on whether those are meters a minute or knots. Sorry, meters per second. So yeah, it's at 0.25. So that would be, if it was meters a second, be actually half a knot. Anyways. That also worked for a while, and then it didn't. And I was going to let you fly this, but it was a handful for me to maintain. So I don't want to set you up for failure. If we were doing half a knot, it would be a lot easier. And if you think about it, what's your average walking speed?
About a knot if I'm lazy.
Yeah.
Maybe 3 if I'm ambitious.
Yeah. So we're now traveling over the seabed at Tim's lazy walking speed.
What's the equivalent of miles per hour to knots?
Roughly 1-to-1. Knots are a little bit slower.
Yeah, that sounds about right.
They're a little bit farther because of the curvature there. So. But for horseshoes and hand grenades, close enough. And one of the fun things about Nautilus is we have every unit that is known to science here. So, for example, in front of me I have knots, I have meters, and not only meters, we have meters a second, and we have meters a minute. And I probably wouldn't have to look too far to get a temperature in Fahrenheit and a temperature in Celsius. So
Roger. For you, Kelvin, side note, Atalanta is working pretty hard to maintain this auto heading. Do we care about that? Should we adjust it, shut it off?
You could shut it off, I think. Yeah.
Auto head off.
Thank you. Good catch, Tim. So Atlanta's heading is being dictated by Hercules.
The giant sea anchor?
Yeah, so absolutely has a sea anchor out right now. I often forget about that. And Hercules heading is being dictated by, is it the dog or is it the, is it wagging the dog or is the dog wagging it?
Some days it's one, some days it's the other.
So I was going to somewhere, this would be a good one for a technical person like yourself. The PID values on this system have been adjusted now and again, and they have been tuned, but there's no like one size fits all for a PID loop. And I have to go back in my pictures and look what the different numbers are, but they look a little wonky to me. And the other watches were saying that Hercules was having trouble holding its heading.
Roger, is that for your autos or for your joy gains?
That's for the autos. So for auto XY, the most difficult one to achieve with an ROV is auto heading. So they want to walk around. They don't want to drive in a straight line.
Yep.
And that depends radically on whether you're going forward or sideways or stationary, right? So you can dial it in for like going forward, but then when you're stationary, the thrusters are, you know, like reversing and it's sitting there twitching. And when you're going sideways, it's like, oh, everything's wonky. And then you add external forces, and it can be. In some cases, I've operated some ROVs where we have a bunch of post-it notes across here, and we change the PID values on the fly. And I should put together a historical PID numbers. And there's no like set to defaults here. So if they get radically changed, then I have to go dig through a bunch of old pictures because I can't remember what those numbers are. But I didn't go there because I was trying to, so I shall do that. What else in here? You know about the utility?
I've heard stories about the utility.
So those numbers, besides making my eyes twitch, the very top one is the filtered vertical velocity. So we mostly use that when we're coming up and coming down.
Is that from the depth or from the DVL, do you know?
It's from the depth, because we get that all the way to the surface. So it takes the depth, and it takes your, I don't know where it gets its velocity from the octans, obviously, and it figures out how long it's going to take you to get to the bottom or to the surface. No, time to surface, yeah. I forget if it switches on the way down. I think it's just time to surface, so it estimates how. But we use that especially coming up, so coming down we go like as fast as we can. Typically same coming up, but if you're running the winch, we can match that speed with this one.
Oh, Raj.
And that will help you maintain the tail-to-tail delta all the way through the water column. And as we go along, you can bump that up. Keep Atalanta 50-ish if you want.
Bring Atalanta up, back to 50.
Yeah, I'll keep it at 50.
Up on winch. See, it just feels weird when I'm moving, 4,000 pounds of something and push the lever and don't see an immediate update in the number that's telling me what it's doing. I get the cameras, they tell me what it's doing, but
sometimes they freeze up and we couldn't figure out why the winch wasn't moving. Well, the cameras were frozen and we never looked at the numbers.
All right, Atalanta 50 meters, I'll stop on winch.
Roger, 50 meters. We can talk about the winch for a minute. So, can't see it in any of these views. I'll switch over to this one for a minute. Have you been down in there?
I've met the winch before, but it's been a little bit.
So it's a traction winch, the 6/8 umbilical as we call it. We call it that because it measures 0.681 inches. Comes up over the overboarding sheave, across the deck, down through the turning sheave, and onto the big wheels you see there on the left of the screen. So it wraps around those like 5 times. There's 5 wraps, and then it goes onto the storage drum. So that it actually goes through a level wind and then onto the storage drum. And the storage drum keeps about 2 tons of tension against the traction part of the winch. And the traction part, because it goes around 5 times, that's where all the force is of lifting the 5,000 pounds of cable up. So the storage winch is just, that's exactly that, it's just storing the cable, as opposed to the winch on the social deck where the power is, or like your spinner fishing reel where you're actually winding it, using the reel to wind it on.
Right, is that because we don't like the 6.8 squishing itself if it's all wound up on a direct drive?
Yeah, so on a typical Dynacon 421 winch, which we had before this traction winch, the tension on the cable at depth is, about 12,000 pounds, and that's when your graph here is alarming. So 12 to, up close to that somewhere. So the very first layer, when you're winding it on, is being wound on at 12,000 pounds. And when you're up at the top, and your last 100 meters or so, it's only the weight of whatever you have hanging on the wire. In this case, 4,000,
Right.
4,000, or less than 4,000, 3,000 something. So each layer has a different profile for the tension, as opposed to the storage winch that has the same tension all the way through.
Regardless of...
So,
Gotcha.
yeah, if you have a lot of cable on the winch, the inner layers can get damaged because of that massive tension that you're winding on there with a small cable like this. Especially when you put some crazy number like 7,500 meters on there. But the biggest gotcha on this winch, or any winch, well, there's lots of them, but the level wind on here. So how the level wind works, the cable goes through a big turning sheave, a 90-degree turning sheave, and there's a couple whiskers, as we call them. And those whiskers are on springs, and when one is deflected, the hydraulics turn on and turn the Acme screw and move the level wind until they're not being deflected anymore. And that's what puts the cable on the drum in a nice even layer. And if one of those, so there's mechanical things in there, there's electrical things in there, and there's hydraulic things in there. So if any one of those fails and we don't catch that, then it won't wind on there nicely, and it will all pile up in one spot. And if we're paying in, and then sooner or later the big pile will slip off and it will trap the inner cables under the pile, and then you can't pay back out.
That sounds unpleasant.
It is very unpleasant, and it will also put huge forces on what's left of the level wind and bend things.
Right.
On the way out, the opposite happens. So the level wind stays in one place and it's peeling off way over that long drum, which is several meters, and it will put huge forces on where it goes through in the level wind that's not meant to have that, and it will bend and break stuff. And that's all repairable, but if the major thing that can happen there is the cable can become damaged, and if that cable is damaged, it's not like we can splice it and cut out the damaged part. It's $1 million. It costs $1 million to put a new cable on that drum, and probably more than that, because it's not like we can go back into port and get one, right? We have to be weeks and weeks before we could get one to a location where we have the equipment on the beach to take the old stuff off, put the new stuff on.
Being Argus up again.
Roger. So people say blue water is boring while we're going up and down. It's actually one of our most critical times, because if something happens to the cable while it's moving, just like your car, right? It's less likely to get damaged while it's sitting in your garage, but if you're out driving it around and not paying attention where you're going to go, it's the risk is higher.
Thanks for that great description and introduction. It was really interesting. So our ROV operators, Dan and Tim, were just talking about the winch and the wire, which is connected to ROV at Atlanta, and that ROV is connected to ROV Hercules. So as we're towing along here between wreck sites, heading towards USS Astoria, it's important that our ROVs are moving at a steady and safe speed. So they were just sort of talking through the different dynamics of ensuring that with our cable, with our winch system.
Atlanta back at 50 meters. I'll stop on winch.
Roger, I'll stop on the winch. You hear me say that all the time, right? I'll stop on the winch. That comes from after doing this for a while and some really bad things are happening and the winch operator doesn't see that, and someone happens to walk by and sees, you know, giant strands of the 6/8 cable peeling off into a giant tumbleweed-sized bush on the sheave wheels. It's, you know, oh, stop on the winch.
Roger, does it sound overly catastrophic if I say that during a normal Atlanta altitude adjust?
No, no. Usually the lingo is I'll say up 5, and you, as long as you acknowledge Roger up 5. Or, the gotcha there is, for example, today on our launch, we were all busy chasing a ghost of a ground fault, which is really annoying, but pretty typical. After the vehicle sat on deck for a while, you know, the connectors are all rubber and lubricated, they dry out. We try and check them all, but there's thousands of connectors on this thing. And I asked Johan to, I think it was Johan sitting there, I asked him to stop the boat because we were moving as we do on launch, and then we're moving farther and farther away from our target on the seabed. And he didn't hear me, and I didn't catch that he didn't hear me and didn't acknowledge. So it's the whole, you know, repeat is good for our spatial awareness up here. So what happened, we sailed off into the wild blue yonder, and it then had spent another, you know, however long we spent troubleshooting a ground fault. That went away at depth, by the way, to move the boat back. Wasn't a big deal because we were able to move back on the way down, but then you have two dynamics, and there's three dynamics that really frighten me in ROV operations. And so basically anything moving. So if the ROVs are moving, if the boat's moving, or the winch is moving. So I try to minimize those dynamics. And too many things happening at one time, in other words. So if the boat's moving and the winch is moving, that means the ROVs are automatically moving, right? They can't help it. And
Everything's connected.
yes, and that's usually when we get in trouble.
Right. I'm gonna bump Atlanta up again.
Roger. You get a
Is there a polite speed to move Atlanta for normal depth adjustments?
That is an excellent question, Tim. Yes, there is a very polite speed, and it's probably about that speed, 10 to 15 meters a minute. If
Right.
Hercules is, and you can in a panic go up to a rated speed, but like dynamics are scary. Anything fast is frightening. Everything should happen slow and easy. If Hercules is sitting on the seabed and you come up too fast, it'll pull Hercules off. And
We have an interesting question coming in from shore. Why do Japanese ships seem to degrade more quickly than the American ships in the same waters? Is that something, Hiroshi, that you might know about? And is that true? Do they degrade more quickly than American ships?
I am not aware of that thing. Yeah,
Yeah,
yeah. It's depending on
Yeah, right.
condition of sea or yeah. I don't think it's yeah.
Copy
yeah,
paste.
I'm not aware of that yet.
yeah. I'm not aware of that either. I'm sure conditions of the sea, time of the wreck sinking or the ship sinking, and the material of the ship itself. So, but as we will be doing several systematic surveys of these wrecks, we'll see firsthand the condition that they're in.
So Hiro will know this one. Why do all Japanese vessels have Maru in their name?
Sorry, can you say that again?
Why do all Japanese vessels have Maru at the end
Oh,
of their
okay.
name?
So this is a good
I know
question,
you know
actually.
that one.
Yeah.
I'm asking the group if they do.
So the Maru is usually the civilian ship, and so usually for example, in the Garao Canal, you can see something Maru next to the coastline because it's a troops vessel. So they beached most of the troop vessel to the beach. So and then actually those are Imperial Japanese Army ships. So they kind of during the war they took the kind of standardized. Some of them are standardized civilian ship or cargo ships, and then during the war, Japanese military or navy, took it, and then so that is why if you see Maru, it's originally it's a civilian ship, so it's not naval ship. Yeah. And then meaning of Maru itself is a little bit complicated, and then there's several theory about what's the meaning. For example, if you put the boy's name, sometimes we put the or kind of ancient time, not commonly popular practice, but little bit medieval time or Edo period, we tend to put the Maru for boy's name, or even the dog's name, Maru, something like that. So it might be come from there, or there's several theory about those Maru, where the Maru come.
So it's a masculine name.
Yes, actually, so yeah, Japanese, I think, yeah, we don't see ship as a woman or female. Yeah, it's true.
That's interesting. I thought it was something to do with. I thought it was more like a term of endearment or something that's affectionate.
Does it, the meaning of it is
Yeah.
circle? Is that right?
Yeah, it's a correct. Yeah, it's a Maru itself. It's just circle, or yeah.
So the military vessels didn't have Maru in their name.
Technically, some naval vessel has a Maru, especially so when the Japanese started to like a modern country. I think some it just changed, Edo period, to modern, government. I think some ship had Maru as a naval vessel, but after most of, especially this, Guadalcanal or World War II era, most of the naval ship doesn't have a Maru. Yeah.
So the idea of the meaning circle is that the ship would safely return back home.
Well, I don't I don't think that is a meaning. Yeah, it's just more to do with like a. To be honest, I don't have answer for that, but yeah, maybe can
Okay,
be.
Quick
Can
handoff of
be. Yeah,
video, 2
yeah.
seconds.
Well, I stumped him
nice.
on the first question. I've got a whole bunch more. So. It's not often we ask a question from the front row and the back row has, well, no, that's not true. I should say the other. We often get differing opinions from scientists in the back row for a question from the front row. Like, what kind of rock is that? Or what kind of animal is that?
What was the first thing you said, Dan? I didn't hear that.
When we ask silly questions up here of the back row, we often get several answers. Like, what kind of rock it is can lead to a very long discussion. Or
That's right.
what kind of animal that is. And then
Yeah, it definitely depends on where we are and what we're doing.
yeah. So after my little temper tantrum there, Rennie, I tried
Oh, I see.
and failed miserably.
I was going to come up and say, look who's in
Epic
tow
fail.
mode.
Well, that was the plan.
Yeah,
It
that's
was,
all good. I'm resetting your DVL, yeah, all good.
Roger. You have to try. If you don't, failure is, there's a bunch of sayings for failure. Builds character.
Yeah.
Humbling.
Just going upslope gently as we go.
Yeah, rumor is, according to that little chart there under your coffee cup, 800 change at the other end.
800, yeah, so a couple, 200 meters ish.
So our ETA to Astoria is about 2 hours and 30 minutes or so. Is that right, Rennie?
That will be when the ship arrives, and then we will have to wait for Atalanta to arrive and get all sorted out again.
Another 3 hours till Atalanta gets there.
Yeah, it's just because so for reference right now, our layback is about 250 meters.
Gotcha.
So you figure that pendulum has to take some time to settle out. And
sounds good.
Yeah.
Funny, that's about the excursion radius of free flyer this depth.
So for our viewers who are tuning in from all over the world, from the US, Canada, New Zealand, Guahan, the UK, Thailand, Solomon Islands, Malaysia, Germany, Australia, and everybody else.
Start the clock.
Thanks for sticking with us as we are transiting to the next wreck site, the USS Astoria. We'll be there in 2.5 to 3 hours, and then we'll start off with a Norbit survey, high resolution survey, and then descend down and do a visual survey of the wreck. Definitely feel free to write in questions if you have them. This is a great time as we're just transiting between sites.
Tim, can you write in the red book that we have a ground fault on Atalanta aft thruster?
Ground fault, Atalanta aft thruster, roger.
Yeah. It's normally 47.9 meg, and it's down there in the concerning range. Turn it back on to give you a number.
Looks like our angle still within spec.
Yeah, barely holding in there.
Yeah.
Did you have a number for that ground fault?
At the moment, it's in the kind of good-ish zone. It's 15 meg. Which is interesting. I'll leave it on for a minute, see if it was dropping down into Ks, so something K. You can write XXK, 2-digit Ks. The alarm threshold is, I believe, 1 mega ohms. 1 meg ohm. Are they recording orbit at all?
Yes. In a separate, just its own little survey.
Oh, oops. What one is it? QC4.
Check, 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 check. When orbiting, we're 50 meters up for both. We're just hawking the sonars, obviously, because now we have a 250 meter layback from the ship. So anything in there is a haul up thing. We're just a gentle slope up. These are 10 meter contours, so we're really gradual. So our depth is now what, 917 plus 50, 975, and we're going to a depth of 850. Just gonna keep resetting your DVL for no reason, but yeah, just tow. We're watching, so our ship is okay as far as that would be, but then the angle, and nominally we say towards the A-frame legs would be a bad angle, but you know, we're there and we're seemingly at the same, not increasing too much. And we're going at 1 knot. Seems like about 50 for both, yeah?
Yep. Mostly just letting it get pulled. Just letting it get pulled. Which comes out to 55 or something well. Yep.
Does this feel fairly different from having to pilot around a wreck when now you just get to be towed through the blue water?
A little bit different. I mean, yeah, Atalanta just kind of goes wherever the ship decides to put it. So, or I guess where Rennie decides to put it.
Yeah.
I get to look around.
you know, boring watch is good when you have lots of moving pieces. We'll take boring
You know
watch.
what? I think we're gonna run across some interesting stuff on the Norbit.
Yeah.
Norbit's
That's gonna be my
keeping an eye.
my thought process. I mean, it's zoomed way out, so like the smaller stuff we might not see, but
It'd be interesting, yeah, to process it and see
yeah,
what's what.
like you see like that little one on the far left, that line.
I don't. This?
Yeah,
Oh yeah, I do.
right there.
Sure. I don't think that'll show up in the voxels, but
No,
but in there, yeah.
a little
Sure.
something, something.
Maybe.
What kind of resolution would you get from this altitude in the Norbit data?
For a
Best
single
guess.
pass, I don't know, at least, you know, in the decimeters. So like those voxels I think are set to be 50 centimeters. And you can see that the underlying data is a bit higher resolution. So you could probably eke out a higher resolution, but then you'd have some more gaps in it, just where there wasn't that density. And because we're towing and kind of wobbling, there might be some places where it's not as dense. But that would be the order of magnitude.
I mean, that's kind of that dropout that you're seeing on the right hand side of the screen, yeah.
Yeah.
Yeah, I mean, some of that is actually it could be,
Maybe a ridge.
yeah, it could be, but it's hard to say. Let's see what our layback is now. If it's not increasing, then that's like, yeah, it's the same. So this is pretty much, as long as we maintain this, I don't expect us to go to layback any further, but
Are we still looking at 3 hours?
yeah, so the ship will arrive in 2 hours and 15 minutes,
Okay.
but it'll take a bit of time for Atalanta to get there,
Yeah.
and for everybody to set back up. Yeah,
And we'll start this process again.
Yeah,
that's
yeah.
right. What's up with that AC ground fault? What's up with that AC ground fault? Was that the one that you were just working up, Tim?
It may have been. Try turning off your aft thruster on Atalanta, or I can.
The aft thruster?
Yep.
There.
Thruster aft.
I'm just going to turn off my auto-alt. That should...
Yep, we got
There it goes.
phase B normal.
So Atalanta's aft thruster is still problematic, yeah?
Yeah. So in yours, it was your aft thruster?
Yep, this guy here. So if I bring it back on, let's see.
Yeah.
Good for now. I know it was kind of intermittent before, so we'll keep an eye.
So here's a lesson about that's our current. It's going kind of
Just hitting us on the on the port side.
Yeah, you see how it looks like it's coming from there?
Yeah.
It's because we're dragging that.
Yeah.
So always, that's just not, that's
That's
not
the
measured.
DP.
Yeah, it's the calculated, yeah.
Yeah. But that's the ADCP, the Simrad one.
That's
yeah.
right. So it's good to
Mm.
know what'll,
What
not that you
choose.
didn't already, but
Yeah.
you know.
Is there a reason why we don't have the ADCP one on all the time? Or
It's
I
just
guess
another
during
sonar
this?
in the water, but
Okay.
I usually just turn it on and look at it.
Yeah.
We're not logging that data. It's a lot. It can be dense. So
Is it usually stay on while we're mapping?
no, we usually just have it on just for launches and recoveries.
Okay.
Unless we have a purpose for it with like to use it as a instead of as an AD, or to record the ADCP data, or to use it as an EK-AD with the fisheries.
Yeah.
The midwater sonar. Oh, now he's flipped the view.
Was K2 processing some of the data from?
Yeah, we flipped over a couple of things, and what we wanted to do is take a see if we could get a patch test where we calibrate out the roll, pitch, and heading biases that we're currently in, or the offsets, and try to straighten out the data. And then we're also seeing some what we believe is tidal data because we took it over 3 hours, and it's little tiny bits of changes.
Okay.
So we might try to get that tide data in there, and yeah, just kind of make sure that the way that we were doing it is going to continue to work for each of the wrecks.
Yeah.
Or if there's anything we need to adjust.
But he's recording all this stuff now, yeah?
Yeah, we were. I'm going to check
with
on
Norbit.
that actually. Chris, you down there in the data lab? This is Rennie and Nav. Yeah, did you stop recording or just like reset the voxels or something? Yeah, okay, sounds good. We'll just watch this. Don't forget dinner. Gotta keep him fed.
Remind K2.
Yeah.
It's that time. I got that ground fault came back on Atalanta.
69K.
I was gonna say during the dive on the wreck that didn't pop up at all. Seeing there goes back. So
Just seeing if that's terrain up there, if it's
yeah,
just edge of sonar kind of for Atalanta.
the little blue.
Yeah, the blue at the top.
The blue, yeah.
Because that would be upslope. So
Yeah,
just have to make
starting
sure
to come up.
Yeah. But I don't know if it's just persisting there.
No, because Herc is behind, so the little blip be at the lower portion of the screen. That's Hercules, but there's a very light tinge of blue up at the very top.
Oh, gotcha.
Because, yeah, so Atalanta's facing the way that we're going, so that would be upslope. So we just
Yeah.
have to make sure that, because we're not gonna, I mean, we're going in knots, so it's gonna come quick. So if there's
Yeah.
anything in there, that we haul up.
It also doesn't look like it's a wall coming.
No, but we'll just make sure that that
Yeah.
doesn't get anywhere.
It is supposed to, I think, come up about 120 meters.
It went from 1020 to 850.
Okay.
So, yeah, I mean, Atalanta's altitude has dropped 3 meters. Could
Yeah.
haul in occasionally. Just keep an eye on it. We normally would not tow at this depth.
Yeah.
It'd be like 100 up.
You just come up.
We would just be like 100 up,
You do what?
like 100, or whatever the terrain is.
Okay.
This is like gradual,
Yeah.
but it's compromised because we're doing some orbiting, but also seems like terrain, you know, there's no terrain, we know that from
Yeah.
the bathy, but if there was, you'd be limited in your capability to address a gear problem if there was, you know, a line or something, but
Yeah.
Speaking
you know,
of,
at some point
coming
you
up
have
with
to just do
Atalanta,
it.
Yeah. Coming up.
Yeah, that's good.
Yeah.
Come up to 50, keep it around there.
keeping it there.
It bothers me so much that those are on the wrong side. It should be port and starboard, because then you'd be like, you would see the,
Yeah.
I don't know why that is.
I don't know. I don't know if that's something video can
Oh,
do.
it's fine. It's the standard way. I don't know why it's that
But if
way.
this is, yeah, but if this is going to be the standard, a standard configuration for the cams now, is to be able to see the arms off of it, and have the cameras all the way aft,
Oh yeah, so what's
facing
going?
forward.
Yeah, what is with that? Didn't they used to face out more?
So you used to face aft, so they were up forward facing aft, but you couldn't see the travel of the craft as it came around.
Sure, sure.
So they said, well, why don't we put it on the aft facing forward so you can see both arms, how far out.
How's
you
your
know.
stereo with the two cams on starboard when you're putting something away?
So what?
How's like the stereo vision when you've got the 2 starboard cams? Now that you've repositioned one of your starboard cams, you still have a good like
You still
view
have
of both.
Yeah, and you have the view of the bio box still coming down on the starboard side,
That's just from the
and then
aft,
you
yeah.
just have it coming aft, so you still have that whole
Yeah,
that
well,
whole area.
I mean, yeah, then those should be flipped. I mean,
Yeah.
maybe we'll get to ask Dave that.
Oh, come on. I think
I can mess around with it, but every time you fire the salvo, it'll go that
That's
way
what I mean,
until
yeah.
Dave makes a
But
change.
we could talk to Dave about the permanence.
Yeah.
Yeah.
If that's where those cameras are going to be aft instead of aft facing forward instead of forward facing aft, we should probably switch those. Too.
Yeah.
Yeah.
You don't want to give Jacob a mission
Oh,
impossible task?
absolutely, he can do it. It's. I know that Ed and Dave are, you know,
Yeah.
they don't like, they want full approval before we make changes to like
Yeah.
the main stuff. Yeah. So Tim, that blue hue went away.
Yeah. So it might have just been...
So do you guys want me to try to swap that around?
Yeah, give it a shot.
Cool.
Take a look at it.
It might have just been
I make no promises, but I'll
with
do my
you
best.
a little bit further down than coming up.
Right, right.
This is cool looking at the terrain, though, with the Norbit and how it slopes off.
Yeah, yeah, it's nice to see the context.
So,
Like we normally see such a like narrow.
well, it was, I mean, we were utilizing Norbit during the Palau cruise, and just we had it for that one dive that we lost the profiler and then ended up finding it. But you know, every time that we dove and stuff, I just turn it on and record because I don't know. To me, it's any additional data is better than no data at all, especially if it's just sitting there anyways. So
I also enjoy, with how wide of an angle it is, how much it looks like a side scan. Like you get the shadows of the things around you, but like
yeah,
actually in 3D.
yeah, exactly.
You gotta ground fault back.
Back on for
Is that
yeah
the
your
same
phase
as mine?
B.
That's the
Yep.
same as mine.
Yeah. The Atalanta. I'm curious with that aft thruster if it has to deal with that that hose.
Oh yeah. The other thing is, we think it's the aft thruster, but also it's intermittent, so it's not impossible that it just coincides with when we push the button.
Yeah.
Let's see, I'm gonna turn it off again, see if it...
Just keep pushing buttons.
Keep pushing buttons.
Oh, it went away.
That was pretty fast. And now if I bring it on again, does it come back?
We'll see.
I also don't know how immediate.
Might take some time. It also just might be some of the wires in line just kind of doing a little bit of a flap and just causing it to do that. Yeah, I don't know if you looked at the dive logs and stuff like that when we were doing the photogrammetry on the wreck itself. I was unable to swap the gauge screen over because we were just looking straight down to make sure we weren't going to tap on it, and I was like, I'm not even going to attempt to try and mess with it, so. Yeah. But I got the rest of the gauge, or of the readings and gauges.
Cool.
You're just having fun up here with all the network stuff, aren't you?
So many things. I have my new toy.
Is that Minecraft you got going on?
Yeah. Exactly that. Chris has his Minecraft, I have mine.
Exactly.
Is that better on the multi-viewer, guys? Is that what you guys wanted up there?
So what?
I think that's what was asked for.
I switched the cameras. Is that what you wanted?
Yes.
Yes. never had to switch around the multi-viewer before. I'm very proud of myself.
Perfect.
Nice.
Stupendous. That's exactly it. You got craft on starboard and you got the Orion on port.
That I'm very proud of myself for that one. I'm not gonna lie.
Not much of a challenge then for you, was it?
I didn't know which picture was which. That was some guesswork.
Oh.
I think that's definitely further into the video router than I've been.
Yeah, that first time going that deep for me too.
Goes deeper than you think.
It,
You're like, oh, I push the buttons and it changes video sources, and then things get frightening real fast.
yeah, I think I was like 4 submenus deep at that point.
Just letting you guys know we're starting to get a little bluish hue again. Nothing.
That shrimp's got some nice red color on them.
Yeah. I feel if because Atalanta dropped to 45-meter altitude. If it starts to come up a bit more on Atalanta's altitude, then we can just pop it back up.
Yeah, it should probably come up.
I have a feeling that blue hue will go away when he comes up. He's at 44. Change. Yeah. 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 Yep. I'll just tell you like.
Actually, Rennie, I have a question for you. While we have a chance, would we be able to restart NavVest? And would that have adverse effects? This is not important, it's just for my side project.
Yeah, restarting NavX.
I'm gonna restart NavX. Do you need to do anything else before I do it? No. So you're gonna lose this. So we can zoom in on us over here.
Alright, stopping winch.
Yeah, those little soundings off to the left.
Oh, that's fun. Is that kind of a downslope we got?
Oh no, the little lighter colored ones.
Oh, yeah. Do you know, is that backscatter or is that relief?
I don't know.
I don't fully know how Norbit works.
Be something to zoom in on and take a look at after processing it.
It looks like he's showing kind of a backscatter brightness with the elevation in the point clouds. Yeah, ground fault didn't come back after turning the camera on, so.
Yeah, I'm kind of curious if it's maybe just one of the hoses starting to kind of do a vibration or what. So.
Oh yeah.
I don't know. But you would think it would come back after a while, or we would see it again. I don't know. It's a good question though.
No, I got snacks. I'm good.
Huh? Yep. Yep. There you go.
Check, check.
I got you.
Okay. You sat there before, Tim?
Only for a few minutes.
All these years? What do you need to know? What's the most important thing you need to know? You've heard me talk about the double tap bug, I think.
On the...
No, on the altitude versus the auto depth.
Oh, gotcha.
We'll start you out with that. So if you Let's see if I can figure out how this works right now. If you switch, if you now select auto depth.
Auto depth.
Yeah, and then go back to auto altitude.
Auto altitude.
No, that doesn't do it. Turn auto altitude off and turn auto depth on.
Auto alt off. Auto depth on.
Yeah, that's how. So now you see your thrusters are 100%, and curiously enough, they're thrusting full up. So if you were like trying to maintain auto depth under the screw, you would get screwed. So now, if you now turn auto depth off.
Auto depth off. Thrusters go back to normal.
Yeah, and turn auto altitude on.
Auto altitude on.
Now they're 100% down. So if you engage auto altitude like that and you're close to the seabed, all of a sudden you're in the mud. We call that the double tap bug. And if you turn auto altitude off and then turn it back on again, it's all good.
Yeah,
so
it's kind of fine. Your Adelant is getting a bit low.
Right, it's way low. I'll warn you right now, I am a horrible Atalanta pilot, so you're going to have to not only learn how to, where all the buttons are there, you're going to have to manage me as well. Yeah, so the moral of that story, I can never remember how that happens, like if it happens if that button's on, like if you have this, I think it's just when you turn one on or off. So there's a couple ways around that. One is to look at your thruster commands whenever you tap one of those buttons, which I naturally do because I've been slammed into the seabed a few times by it. And the other one is just to double tap it. So
Gotcha.
It'll never happen. I've never seen it happen. So usually when I'm at depth, I very rarely use auto depth. I only use auto depth if I don't have altitude. Or K2's yelling at me for some Norbit survey. The reason for that is the vehicle behaves better off of auto altitude because using the DVL and the big 4 beams.
Did our boat stop or go in a different direction?
No, it's still going south.
Still going south.
Oh no, it's making a left turn. Good eye. Navigator should have caught that. Navigator still hasn't got a clue. Oh look, your software caught it.
That's where I saw it. I was looking over there.
I forget.
Hypax also.
What's that?
Yeah, Hypax also shows it, but it looks like we're still good. What's the course over ground in mine?
It's
or in that one?
215. In yours, it is
Hopefully the same.
Nautilus, course over ground.
Should be the second line under Nautilus.
Oh yeah, you got speed in. Yeah, it's 196.
Still moving. Atalanta's a bit low again.
Roger. Why is the vessel taking a holiday?
For what? For here?
Oh, that we were going 180, now we're going 188, and we were going, like, if you look at the track line, it's gone to the west.
I think we're just getting pushed around because we're maxed out DP.
Roger.
Can you zoom in and out on yours too?
Sure can, but you need a computer that has control.
What computer is it on?
It is on DLab 1.
Yeah, I can do that here. Oh, look,
So
it's intuitive.
good spacing is, oh yeah, it's scroll in Apple directions, because Apple computer. Good
Yeah.
spacing, 10 meters.
And is it on some kind of auto center, or
Nope,
you're
full
managing that?
manual center, so
Roger.
you gotta keep up with it. Ooh, we got a ground fault back on Argus, probably the same one.
Yeah. So, 2 meg is okay. It's just scary because it's red. 690K. So you saw it in the Ks?
Yep.
Yeah.
Just barely.
Ks
6
are
to
bad.
9K.
Ks are bad. Wait, where was I? You probably don't need auto altitude. You can.
Don't need. Can take it off. Were I to want to adjust the auto altitude,
So. Yeah, but that is very dangerous. And in general, on this system, if I want to adjust my altitude, my heading, my depth, I turn the auto off, make the adjustment, and then turn it back on.
Roger,
So
auto lock in.
if you think of it as, cruise, the danger there, especially with auto altitude, you can adjust your auto altitude below the seabed.
Yep.
The other danger, if you don't hit the seabed, you have all that velocity coming down, and the thrusters will reverse once it gets to the set point. Visibility is gone.
Right.
In some cases, tragically, where you can't see. But you can step up or step down with the caveat of the step right now in Z is 0.5. So if you clicked step up, it should, your goal should change accordingly. But I don't know, yeah, it did. So if you click it again, click it a couple times.
I don't see goal changing. It still seems.
No, and it's not thrusting up. I think it only does that when you're in auto XY.
Roger.
And to be in auto XY, you have to have the button enabled. But the other way you could do it is to adjust the stick, pull on the stick. But I like never do that. The only one I will use, if you have, so the auto function I use the most is auto heading. So I'm quite often in and out of auto heading. The heading velocity and the heading step values will determine how fast it moves when you have auto heading on. And the little yellow dot right here, that is your that's your current set point. So, and it's another bug, I think, on Atalanta. Like if I turn on auto head on Atalanta, no, it doesn't work. It's supposed to, that dot should go on and off if you have that auto function on or not.
Gotcha.
But like with Atalanta, you're changing the set point like that, and you can change it all the way halfway around the compass, right? It won't go anywhere because it doesn't have the beans. With Hercules, with auto head on, if you deflect the stick, so I turned auto head on.
Auto head's on.
Yeah, if you turn the stick now, you'll see the yellow dot move.
Do I see the yellow dot move?
Yeah, you'll probably have, twist it.
Oh, got to twist, right.
As he.
Okay.
But you see, as soon as you let go, it snaps back to your current heading.
Gotcha. It snaps back to current, not where it was before.
Yeah.
Okay.
Otherwise, and that's the proper behavior for ROV, in my humble opinion.
That's
Otherwise,
least likely to be surprising.
yes, yes. So when you're moving, when you deflect this with the auto on, when you deflect the stick, you have control of it. When you let go of the stick, the auto re-engages. That's how that works. And
does that work for the verts as well?
I do not know because I do not adjust my auto with the vert on.
Roger, let's find out. Let's see, we're in auto out at 4.6 meters. Oh yeah, goal is 4.5. If I...
Is it
Does
adjusting
it push
the goal?
forwards to go up?
Push forward goes down. We
Push
think
forward
we're
goes down, airplane.
We think we're airplane.
And if I pull that,
Yeah, it is
then
adjusting
it moves,
the set point.
adjust the goal, and then I release, puts it there.
Yeah.
Cool, good to know.
And then, of course, if you changed your step points, the danger is the default step points after a rebooter is something silly like 1 meter. We often operate pretty close. So if you pull that stick, it quickly adjusts a couple meters, and it will, by the time you figure out what's going on, you're in the mud where the viz is gone. So the other danger with auto altitude is it thrusts up. So we, in general, we typically try to float up, and we only thrust down.
Right. All right, well, my delta's kind of high, so I can, do these buttons work?
Yeah, absolutely. We use those all the time.
Auto depth.
Yeah, auto heading can come back off too.
Heading off.
And it should just float up.
And the one labeled depth controls altitude, is there a control which it is?
What's that?
Is there a control that determines whether the sky is depth or altitude?
No, it selects whatever one you were using last.
Roger, that's fun.
Yeah. So that's something I usually check when I sit down. Most of us, in general, only use auto altitude.
Right. There's,
and that's
except for in orbit, few reasons to auto depth.
Well, we usually use auto altitude in orbit depth too, but
I guess that makes sense.
Chris claims that it was more benign, and that's because the PIDs are all wackadoodle.
Yeah, you really don't want to use auto altitude when you're going over the wreck and stuff anyway. It would be all...
that makes sense.
You want to be constant altitude over the ground.
That's true, but not true, because it's a DVL, so the beams are like way out there.
Yeah. Yeah, but two are facing forward and two are facing sideways, and...
Yeah, yeah. But yeah, true that, partially.
So we have a...
It will, like if you're flying along and it's flat and all of a sudden it starts going uphill and you have auto altitude on, it'll plow you right into the hill depending on what your velocity set, because it can't react fast enough. Or the average of the hill is not enough, and we're too low. But yeah, so the autos can be helpful or a hindrance. And one of the other, the other controls on the joystick, on the Joy box, vintage Joy box that I use all the time, are the Joy Gain rotary dial.
This guy.
Yeah.
The one labeled Joy Gain.
Yeah, and you have to have the silly button enabled up there. No, I think it's this one enables. One of those enables it.
Bias gain enable.
Yeah, that's really silly that.
And that just enables the knob on the joystick, so I can still set joy gains up here if I wanted to.
Nope, you can only set them with that encoder.
Only set them with the encoder, Roger.
That I know of. So
26.
I'm generally around 65, 75% if I'm flying around something. And your heading is a lot gentler also in auto heading. And that might have been part of their problem today. They were 100% joy gain. So the only time I go to 100% joy gain is launch and recovery, or when I want to get somewhere really fast. Like, you know, we're going 1 knot I'll obviously want full beans. Transiting through the water column. If I really need to come up fast, like, I'm panic mode, pull up. But, or if I'm dragging Atalanta or I'm picking up, something heavy or something. But Herc behaves really nicely between 65 and 75%. It's, with all the autos off, the heading doesn't walk around too radically to make everyone in the room dizzy, including the operator. And the verticals aren't going to slam me into the seabed too fast. And the knob next to that is the Z bias, which we talked about, yeah.
Does the button labeled encoder next to that affect what it does?
Yeah. If you toggle that, it does nothing because none of those things are hooked up and those functions don't exist anymore.
Roger.
Yeah. Historically, they did the suction pump, and I think there was a silt pump or something on here that's not on here now. So we've taken those valve packs that controlled off the vehicle and upgraded with the new sub-Atlantic valve packs. But also when I first sit down there, one thing that does work on the touch screen is the 0 Z bias. So I never know how light or heavy the vehicle is, depending on how many samples they've picked up or, the depth is changed or whatever. So I'll get a feel for how fast it floats up off the seabed. Uh-oh. I'm gonna go off comms for a minute for geek huddle.
Roger. Let me know how it goes.
So, K2,
Pear-shaped, I can already
do you
tell.
want to give an introduction since you just joined the watch, Chris? Hey, Chris.
We're good.
Do you want to give an introduction on SPL since you just joined the watch?
Hey.
Hey.
How's it going? I'm Chris Krasnowski. I'm here doing navigation and high-resolution mapping.
Nice. How about sharing a little bit about the Norbit survey process for...
Say again, sorry?
Do you want to share a little bit about Norbiting and...
Yeah, so we have a high-resolution multi-beam sonar on Hercules. It is called a Norbit WBMS. It's sitting on the front of the vehicle. We use it to give us in early sort of guidance on dive maps, so we can do a quick overview of the site. It'll tell us if there's any snags or any obstacles that we need to watch out for, and it also gives us a nice reference as we're driving around. Yeah, it sort of has the advantage over the ship multi-beam of basically, one, being a higher resolution sensor, but also just being closer to the seafloor. It's like taking a picture with the camera. The closer you are to the object, the more detail you can get. The multi-beam is no different, so.
Nice, thanks. Yeah, so the plan is that we'll do a Norbit survey at every wreck so that we have a high resolution map of each wreck before we descend down for the visual surveys. And for everyone who's still with us online as we're towing to our next site, the USS Astoria should be there in a couple hours, and then we'll start our Norbit survey and then descend down for the visual survey. After the Astoria, we'll be heading to the Quincy, and then we'll be heading to a couple of Japanese ships, the Ayanami and Udachi. Hiroshi, do you want to share a little bit about those Japanese ships, since you're kind of our expert on...
So yeah, those ships are destroyer, and actually this is some kind of outcome of Washington treat, and So yeah, those two shipwrecks are destroyers, and then this is something outcome of Washington Treaty, and because Japanese had so much regulation to build the ship, so Japanese has to come up with unique idea to compete with British or Americans, and then so kind of manifestation of their tactics to use torpedo to against those U.S. or so yeah, those two are very interesting as a tactical aspect. Yeah.
Yeah, absolutely.
So the Ayanami is a Fubuki class, and the Yudachi is a Shiratsuyu. And what's cool about them is Japanese destroyers had like really low drafts, so they only sat maybe up to 12 feet deep in the water, so that made hitting them with torpedoes even more difficult because there wasn't as much to hit.
Awesome. Thanks for that addition. Bill, our ocean science intern, has been doing a lot of research on the different classes of vessels and distinctions between them. Do you want to give a little kind of overview of some of the research you've been doing?
What I've been doing is I've been gathering, or what I just finished working on now actually was a guide to how to identify which class is which. So, the Ayanami is a Fubuki and the Yudachi is a Shiratsuyu, but, how, just looking at those, can you tell which is which? So I've made a paper that has how you could tell, like, oh, this one has 6 cannons, this one has 5. And then I also listed, out of all the ships that we know are in the Iron Bottom Sound, which class they are. And I was also wrote a paper yesterday of how you can tell between the 3 major classes that here at Guadalcanal: battleship, cruisers, and destroyers. So I think that might be getting put on the blog soon, so y'all can check it out there.
Awesome. Yeah, so for all of our viewers who are interested in digging into more of those distinctions, as well as some of the history of this region, we do have several blogs up on nautiluslive.org that you can check out and learn more about this expedition and all the planning that went into it and all of the history behind what we are doing right now. So feel free to write in questions because we're just towing through blue water for another couple hours, and we are here and available to answer any questions you might have. And for those who are asking, yeah, the plan is that we're going to stay in the water and do a really long ROV dive. So typically our dives are a bit shorter, and we're currently planned to be in the water for a few days at a time. And since these wrecks are relatively close to each other, it makes sense for us to stay in the water and just tow between wreck sites. And then we can descend back down from our towing altitude, which is roughly 50 meters above the seafloor, and then an orbit survey and do a visual survey of the wreck, and then move to the next track. So in addition to the kind of surveys that we're working on, we're really focused on honoring all those who were part of these battles and who have kept the memory and sacrifices of what happened during the battles of Guadalcanal and the significance of this place. And so this archaeological survey and maritime study of this area is in honor and in deep respect for all of those who were part of this history. And joined with us on the ship, we have several experts, archaeological experts like Hiroshi, as well as Frank, and mapping experts, imaging experts, all of our ROV operators, communicators, and video engineers, and many scientists and experts, archaeologists ashore. I believe we have around 200 ashore and 6 who will be joining us from time to time on audio comms to share their expertise as well with the history of this area and these sites. So it's definitely a multifaceted expedition with a lot of different people involved. We also have a shore team, the Drix, the shore-based team with the Drix vehicle, which is a high-resolution mapping surface vessel. And they're out mapping every day throughout the sound, and that's really supporting our ability to identify sites to do these dives. And then once we're on those sites, then we get closer to the wreck and we can do even higher resolution mapping than the Drix using the Norbit. So a lot of different things happening in tandem and all working together. And yeah, it's going to be a really exciting couple weeks here. So thanks for everybody who's tuning in still. So we have someone asking how long we're going to be in the Iron Bottom Sound region and how many ships we plan to survey if the sea surface conditions are good. So the expedition is about 21 days long, and we'll be heading back into port around July 23rd. So we still have plenty of time. And on this particular dive, which is planned to be 96 hours long, we are planning to survey around 8 wrecks, and it'll just depend how long each dive is, how many wrecks we will survey, and the conditions throughout the cruise. But we should be throughout the sound surveying as many wrecks as we are able to.
Yeah, I think the overall goal is just as many as we can get to in the time we have.
Exactly, yeah. Yeah, so it's kind of a... yeah, so it's... we just have an operations discussion, so we'll get back to that question in a moment.